This is Dr. Memari, and I'm going to video record our experiment 1 from 1045 lab. This is the first experiment that you will be watching, so I'm going to have to explain where to find things. But before we get started, I want to remind you about the personal protection. That is your lab coat. You must have your lab coat on whenever you are in the lab, and your safety glasses, your goggles. You must have long pants, closed-toed shoes. Those are required for the lab. About the experiment, you must have a lab manual for this experiment. And for all experiments, you do need the lab manual. So make sure that you are using the lab manual and you're reading the procedure from the lab manual, because without the lab manual, you're not going to be able to differentiate between different methods of, like, a simple procedure like measuring mass. For measuring mass, like, we have like 3 different type of measurement: measuring out, direct measurement, or measuring by difference. And unless you read the lab manual, you're not going to get the difference, and you say, like, what is missing the initial or missing the final mass? But you need to read the experiment from the lab manual. Look for a link in D2L. There would be a video showing where to find the worksheet. So in Achieve, you are going to find follow the video and find the worksheet that we need for experiment 1, download that Word document, and as you watch the video, start recording the numbers in the worksheet. Then you save it as a PDF, you submit to in the assignment folder. So here are the orders. You read the experiment from the lab manual, then download the worksheet, then start watching this video. As I perform the experiment, you are going to look up closely and record the numbers as you see. Okay? Measurement requires a measuring device. First part of this experiment is measuring mass. There are different methods for measurement. Measuring directly. The measuring device is the scale that we are using. This specific scale that we are using, it shows 3 decimal places. And that means the accuracy of this machine, it's up to the 1,000th place, and you must record all those decimal places. Even if it's 0, you must record that. We can change the unit here from gram to milligram. I'm just showing the gram and milligram option, but for this experiment, or for the purpose of 1045, we will be using gram. There is a tare function here. What it does, it ignores whatever is on the balance pan when you tare that, so it starts from anything you add right after that step. So for the first part of this experiment, which is measuring directly, or measuring mass directly, I am using the weighing paper. This is just to protect. You don't need this for measuring directly, but I am using this to protect the balance pan from the chemical and anything that I place on it. Since I don't need the mass for the weighing paper, I'm going to press the tare function, and it shows 0, and it's very sensitive. If I move my hand over, that number is going to change, which I'm going to have to wait until it shows 0, and then I place the first item. When you look at and you see in the data sheet, the first item we are measuring is going to be a single penny. So I take the single penny, and I'm going to place it on the weighing paper and wait for the mass to stabilize, and I record that number, and I want you to record that number. Watch it carefully and record the number with all decimal places that you have there, that is provided by this scale. And that's it. You remove the single penny. I'm moving to the next item, which is the mass of 150 millimeter beaker. The 150 millimeter beaker is what the label says, 150 milliliter beaker. So again, I need the scale to show me 0. I have the protection, I place the object, and I record the mass. So look carefully and record that number with all decimal places. That shows the significant figures or proper number to be recorded for this measurement. You learn about the significant figures in lecture. In the lab, we put that in practice. And what we do here, we want to make sure that the number we are recording, it represents the accuracy of the measuring device. If I record too many decimal places that is not showing on the scale, is a fake number, is not ethical, I cannot do that. And if I only record one decimal place here, then I'm not presenting the accuracy of this device. Now I have a nickel on the scale, and that's the mass. We are going to focus and record the exact number we have for that for the nickel. Next item, 100 milliliter graduate cylinder. So I would remove the nickel and place my 100 milliliter graduate cylinder. I want to make sure it's 0, and I place the 100 ml graduate cylinder. Record that number. And the worksheet that you have downloaded, and move to the next one. Next item would be our watch glass. That is the next item. The watch glasses, they come in different size. So the mass that we are recording is just for this particular one. Often students, they take another graduate cylinder or another watch glass, and they say the mass is different. Yes, the mass is different, even if the size is looks the same, but the mass is different. Okay, we are done with part 1.1. That's the measuring mass directly. We are going to move to indirect measurement. In the indirect measurement, the method is slightly different. In this case, you are going to look for how much of the substance you need to measure. So the worksheet, it tells me to measure 2.750 gram exactly. I do need the weighing boat or weighing paper. This is like a shiny paper that it doesn't react with my chemical when I'm doing the measurement. Always use a clean one for a new compound that you are using. And you place the weighing paper on the scale. You do not need the mass of the weighing paper in this case, because you just want to measure 2.750 gram. So you are going to use a clean spatula, and since it's NaCl, that's what the compound that I have here, I'm going to take a small portion at the time and add until the mass reaches to 2.750. And it's not going to be easy, because getting 0.0 exactly at the end, it might be challenging, but watch me. I'm just adding small amount at the time until it gets to that point. If you have extra, you can remove some and try it again until you get to exactly 750. As I said, this is going to be taking some time, and you be patient, and whatever you take from that scale now, you're not going to put back on the container, you're going to discard it. And okay, so we have 750 it moved back down to the 9, so I need another grain. That's it. Okay. We are not returning this to the container. It's going to go to the chemical waste later, but for now I'm placing in that beaker. Make sure all the containers are closed at all time unless you are using. Next one is measuring 5 grams of calcium chloride. Now, again, this is like measuring out. I do not need the mass of the weighing paper. Make sure it's paired and it shows 0 to begin with. Take the calcium chloride anhydrous and start adding 1 spatula at a time until it shows 5.00. Okay, 5.000. And we move to the next item. Our next item is 22 grams of water. To measure 22 grams of water, of course, I do need a container, empty container. But again, because it's measuring out, I do not need the mass of the container. I only need the mass of water to be 22 grams, and exactly 22 grams. So I press the tare function again and start adding water until is 22. Carefully, without spilling the water on the scale, add enough to get close to 22, and then the last part, it should be adjusted with the dropper. By pouring, it may not take you to that exact number, but if you get close to 22 and then use a dropper to adjust the mass. Basically, you're adding 1 drop at the time. This part, this type of measurement is going to be more time consuming because you want exact number. Okay. Next type of measurement is measuring by difference. In this type of measurement, we do have and need the mass for an object by difference. That means the mass of the container subtracted from the mass of the container plus the sample. Okay. Next step is measuring the mass by difference, and to measure the mass by difference, we are going to need the mass of the container and then the mass of the container plus the sample. The first, if you look at the worksheet, is asking for the mass for 50 milliliter of water in a graduate cylinder. So I need the mass of the graduate cylinder by itself. I'm using the weighing paper just for protection again. I don't need the mass of the weighing paper, so I tear in this step. And I place the graduate cylinder, empty graduate cylinder, on the scale. Record that mass as the mass of the graduate cylinder by itself. Then add 50 milliliter of water to the graduate cylinder. Again, you want to go as close as possible to 50 and adjust the last drops by using a dropper until the meniscus, which is the lowest point of the curve in the liquid in the cylinder shape equipment, is aligned with a 50 milliliter mark. So we are going to add to make it 50 milliliter. It's a graduate cylinder, so it's not as accurate as burette or pipette, but still we want to get it as close as possible to the 50 milliliter using the graduate cylinder. So I have 50 milliliter where the meniscus is at 50. I place it back on the scale, and this transferring of water is better to be done out on the side, so no water would spill on the scale. So now we have the mass for the graduate cylinder plus the water. When you subtract, you get the mass. So make sure you record these numbers and do the math. Next, it's mass of the first or second and the third spoon or spatula of the sodium chloride. So what we do in this case, we are going to use a weighing paper. And because it's the mass by difference, I need to get the mass of the weighing paper itself first. So I have to tear the scale. Okay, I place the weighing paper on the scale. I get the mass of the weighing paper first, and I record that as mass of the weighing paper. Then I start adding spoon by spoon, so which is the first spoon. So I add 1 spoon of the sodium chloride, which is the table salt, to the weighing paper, and that's 1 spoon, and I record the mass for the first spoon or after adding the first spoon. Then adding a second spoon of the salt, I record the mass after the second spoon. And since it's asking for 1, 2, and 3 spoon, I add the third spoon of the salt and record the mass. Please note that the mass of the, after you do the calculation, the mass for the first, second, and the third spoon may not be exactly the same, because a spoon is not accurate measuring device. And that's for the measuring by difference for the salt. Next, which is the last part of this experiment, measuring mass of the calcium chloride, that is going to sit for 15 minutes. So what we are going to do here, we take 1 spoon of the calcium chloride, okay? We are going to measure the mass. 1 spoon of the calcium chloride. So measure the mass of the weighing paper. Then add 1 scoop of the calcium chloride. Okay. This is calcium chloride anhydrous. Okay, what it means that has lost water or there is no water. It's very good. It absorbs water. It gets hydrated, so it absorbs the moisture from the air. So if we leave it out for 15 minutes, as it sits in the air, it's going to absorb water. The mass is going to increase. It's a good practice, and the purpose of this experiment for you to know that if something it says anhydrous, it has a potential to absorb water from the air. So as soon as you use this sample, you must close the cap. If not, it's going to absorb water. It becomes like a rock. And it's not going to be efficient whenever we need this to use as an anhydrous agent to absorb water from any like oil or organic liquid that is not water soluble. You will learn the technique later how to use it, but at this point, anhydrous agent like calcium chloride is going to absorb moisture from the air and the mass is going to increase. We are going to wait for this 15 minutes and we come back. Okay, we waited for 15 minutes. Now the calcium chloride, which is an anhydrous agent, has absorbed water. Now you look at this number, the mass has increased. I didn't change this sample. It was just the moisture absorbed by the calcium chloride that increased the mass. And we are done with measuring the mass. Here's what we are going to do. All the chemicals that is used needs to be disposed in the solid waste container. And we want to make sure the scale is maintained properly. So when you are done with measuring mass, there are brushes next to scale. Make sure if there is anything spilled, any powder, you are going to remove it carefully and dispose in the solid waste. Just as a wrap up, here is the tare function whenever you need to use the tare for measuring, like directly or measuring out, and then changing the scale, like a measuring unit from gram to milligram or back and forth if the procedure calls for it. Now we are done with measuring mass. We are going to move to measuring volume, next part of the experiment. Okay. Part 2 of experiment 1, it's measuring volume. To measure volume, we have measuring devices used in the lab. One is graduate cylinders, and then we have a burette. We also have numbers that gives approximate volume for beaker and for a Erlenmeyer flask, but the ones that are more accurate for measuring the volume, it would be burette, and sometimes we need to use pipette. Those are most accurate. For the purpose of measurement, we are using this 5 different setup already. The purpose for this part of the experiment is to be able to record the volume as accurate as possible based on the measuring device. So when you are measuring, your eyes should, or reading this number, your eyes should be at the level of the meniscus, not too high up or too down low compared to the level of your eyes. And when you look at this measuring device, like for the 10 milliliter graduate cylinder, there are some numbers on the device. So measuring device. So we know the liquid is between 7 and 8 in this case, is between 7 and 8. Then there are smaller lines that those are not imaginary lines, those are the numbers lines that we can see and is provided by this measuring device for us. So we can only count like how many higher than 7 here. So if you look at these numbers in this case, it's 7, 1, 2, 3, 4, 5, 6, and then 7 line over 7. So because these small lines, there are 10 of them, each small space between 7 and 8, since it's divided by 10 and we have 10 units, each one of them represents 0.1. So if I'm counting down up, I'm counting this level of the liquid would be between 7. Let me look at it closely. It's between 7.5 and 7.6, and I'm looking at the meniscus. So it's not going to be recorded less than 7.5. It will not be recorded more than 7.6. It's between 7.5 and 7.6. And the last digit has to be estimated. How do you estimate that? You mentally divide the space between a 0.5 and 0.6 by 10, and then see how high is compared to 0.6 or how close is to 0.5. That's what you are looking for. We are looking for the level of the meniscus to be matching to what level exactly. There are 2 digits that I'm going to record here. Those are certain digits. That would be 7.5. And since it's between 7.5 and 7.6, you have to look close up to this level and estimate the last digit, which is going to be between 7.5 and 7.6. Now, if I'm using 100 milliliter graduate cylinder, the idea of measurement is the same. So if we have this level of the liquid, okay? The level of the liquid in this case, and I'm going to change so it's not like exactly as 70, so you can do the estimation. So this number, the level, again, we are looking for meniscus, is definitely between 70 and 80. But the device is providing me smaller units, and each unit here is 1. Between 70 and 80, there are 10 milliliters. So each one of these lines would show 1 milliliter. If this, and I'm gonna have to stop so it doesn't shake, so I can look at the number exactly, okay, is between 71 to 3. So between 72 and 73. And now between 72 and 73, there is this small space that I have to mentally divide it by 10 and estimate exactly. We will get like a still shot of this for you to estimate, but I want to, for purpose of explaining, I'm holding up and it's moving around, but we want to make sure that you know how to read it, and you will be provided by the still shot of this. So you can estimate the number. This is your job to do it, so please estimate that number exactly, what it is when you see it on the still shot. Next one is measuring volume, or basically is the reading in the burette. Why do we call this reading in the burette, not volume? Because we are not counting how much liquid is here. These numbers increasing from top down, from 0, and it goes down to like 50 here, and then stops the numbers there. So when we are reading the burette, we basically expressing what is the level of the liquid. Burette is used to transfer liquid out. So let's say if I want to have 10 milliliter, I start from 0 and I go down to exactly to 10. Or if I start with the 13 and I transfer down here, I want to find out how much has been transferred. You will use this for the following experiments, but for today's purpose is just learn how to read this number. Why I'm holding this white background around it, it's just the better technique of reading the number for the meniscus. It's easier to see with the white background, and the purpose of this color is just to make sure that you could see better behind the camera. So what is the level now again? I have to look for adjust the level to bring it to my eye level. So I bring it down, making sure that it doesn't hit and break the base here. So this number is between, again, 12 and 13, but the numbers are increasing up, down. So it's going to be between 13, and you already know that each small line, it shows 0.1, because between 12 and 13 I have 10 space, and it's going to be between 12.9 and 13, and you are going to estimate that exact number with using the still shot. What is that exact number that you can estimate based on the level of the meniscus? I gave you enough information. Is between 12.9 and 13, so it's going to be 12.9 and something. Beaker is not the best device for measuring volume. It's not accurate. If you measure like 20 milliliter with beaker, you transfer to that graduate cylinder. It could be anywhere between 18 to 22. So, and that's just the number hypothetically I'm talking about. Is not always it's not going to be accurate number, because beaker, it's for transferring, it's for mixing, it's for heating up the liquid, it's not for measuring the volume. But we could have approximate volume. So this approximate volume, pay attention to the side, increasing and then decreasing. This is how much you transfer out. This is how much the liquid is in the beaker. So this number now increasing, if I look at the number on the right side, it shows me about 150. Now, if you come to tell me it's like 150.1, yes, it looks very fancy, but it's not ethical, because this device doesn't give me a 0.1. So you cannot record any number with the decimal places when you are using beaker. Notice that for burette, your number must have 2 decimal places. With graduate cylinder, the number you are recording must have 1 decimal place, and for 10 milliliter graduate cylinder, your number must contain 2 decimal places, because it's more accurate than the 100 milliliter graduate cylinder. The last station that we have here is the volume in a flask. Again, volume in a flask, it's not accurate number, it's approximate number. So between 75 and 100, you have like 25. You can again mentally divide this by 25, this space, and see how many higher. And because of the shape of this flask, that the higher it is, it's narrow. It's not as easy as estimating this number by mental math. You just have to estimate that it's between 75 and 100. So if you tell me that is anywhere between like 85 to 95, I take that, because it's not accurate reading, regardless of how close you look at it, because it's not designed for you to measure the mass. So you're recording all these numbers with proper number of decimal places, as accurate as possible, in the worksheet for part 2 of the experiment, part 2.1. Next part, which is part 2.2, we are going to measure the volume of the test tube. Test tube is not like a perfect cylinder, so we can, one technique that we can use to measure the volume is see like how much liquid can hold. basically. So in order to find how much liquid it can hold, but I have two ways to do this, and when you read the lab manual, it tells you which part, what you can do. One of the options that I use here, I fill up the test tube to the rim all the way to the top, and find out how much liquid is that by measuring the volume using a graduate cylinder. Since we already know how to use graduate cylinder, so we are going to find out what is the volume of the liquid in this graduate cylinder now. And I filled it up to the top, all the way to the top, and okay. Now we can transfer to a graduate cylinder and measure how much liquid is in here. So we are going to look, we already know how to use this. We are looking for the meniscus, and it's a number. The meniscus, again, it's a number between like a 60 and 61. Use the still shot to get that number exactly, but that's how we are measuring. Next, we are going to measure volume for a golf ball. Now, if it's a golf ball or a ping pong ball, we are going to assume this as a perfect sphere. In order to measure the volume, we do need the diameter to calculate the radius, and the formula how to calculate is given in the lab manual. That's why you need to read the lab manual. For me to measure the diameter, I'm going to measure the height of this golf ball. In order to measure the height, it's easier for me if I use two rulers and measure the height, when it's like the one ruler parallel and the perpendicular to the ruler that I'm measuring the height, and see like what is that number exactly falling off. So this number now, I can see that is a number between like a 3.9 and 4 centimeter. The unit on the left side in centimeter is used, on the right side is inch, and we are using the one on the left side, so is between 3.9 and 4, and you are going to again use the still shot to estimate the last digit, so 2 decimal places, and do the calculation using the formula given in the lab manual. Now, if the object is like perfect shape, we can use the dimensions to calculate using math equations. If the object, it doesn't have a perfect shape, like this zinc pellets or pieces of the zinc, I have like 20 of them. And why I don't use only one? Because it's too small and the increase in the volume is not going to be significant, so I'm using like 20 pieces of that for that reason. I can use this technique, it's called measuring volume by difference. Measuring volume by difference, I need to record the exact volume of the liquid I have here. If it's empty graduate cylinder, you pour as much as you want. It doesn't have to be filled up, of course cannot be filled up, as long as you have enough that the object is going to immerse in, or it's sinked in the water. So we record this volume exactly what it is, and then we are going to add the pieces of the zinc. When we add the pieces of the zinc to this, the volume is going to increase. Of course, is the solid is going to displace the water, the level of the water goes up. We have the final volume. We record this final volume. Since we already know how to do this measurement, we just look at how many lines higher than 60, and then between which 2 lines, and you estimate that last digit, which is the first decimal place or 1 decimal place, using the still shot again, or the close-up. Next, we are going to measure the volume for this a box. Now, it's a perfect rectangular shape box, so I can just measure the dimensions, the length, the width, the height, and use again the formula given in the lab manual to calculate the volume. So for this one, I'm using a ruler. I go from the edge, and just to make sure that the ruler is aligned straight, I'm using the corner from one corner to the other corner. So if 0 is aligned one corner, the other one, that is, to me, is like exactly at the 21, and you can record that number as a 21 point. You need 2 decimal places, so 21.00 in this case. Then you measure the width the same way, and from 0 you go to see what number it aligns, and this is what's important for us. The age aligns to what number exactly. So it's between 14 and 15, is between 14.5 and 0.6. You estimate the last digit. Okay, 14.5 something, and that's something you would estimate that. I also need the height. For the height of the box, I measure this again as the number. The height is falling between 8 and 9, is 8.5, is between 8.9 and 9, 8.9 and 9, and you are going to estimate the last digit yourself. That's for measuring the volume of the empty box. Okay, part 3 of the experiment 1, we are going to measure density for different solids and liquids. When we measure density, because it's like an indirect measurement, we have to measure mass, we measure the volume, and we calculate density basically. The first item we are going to measure the density is the density of a golf ball. For that, we need the mass of the golf ball and we need the volume. To measure the volume, we need the diameter, we need the radius. So we already did this measurement once. We know how to do the measurement for the diameter of the golf ball. And then we divide that by 2 to get the radius. Then we are going to measure the mass. For the mass, just for protection of the scale, I'm using the weighing paper again. Make sure that it's tiered, because I don't need the mass of the weighing paper in this case. I place the golf ball on the scale and we record the mass. The mass for golf ball with 3 decimal places needs to be recorded, and then we can do the calculation. Now, for next object that we have is a cylinder that is, it's consider this as an irregularly shaped object. It's a solid. I need the mass and I need the volume again. Because it has this little hole in here, I have to make sure that the volume is recorded perfectly, so I cannot use dimensions in this case. And I want to learn the technique. If the object is irregular shape, if you have a piece of rock, how would you measure the volume? So we are going to measure the mass. That part is easy, and I will measure the mass first. Make sure the scale is tiered, and I place the object on the scale, record the number, and this is in grams. We record that number for the mass of the cylinder. Then we are going to measure the volume by displacement, just like the pieces of the zinc. Because this object is heavy, I want to make sure I show you how to like slide it down to the side so the water doesn't splash. We are going to place certain amount of the water, and it doesn't have to be exact number, but we are using this volume here, and use the close-up to record that number exactly what it is. Then you are going to slide the piece of the metal down the graduate cylinder carefully. I tilt it this way and I go slowly because I don't want the water to splash. And what happens here, the solid is going to displace the liquid and the volume of the liquid increases. Now we have a new volume, which is called the final volume. When we subtract the initial volume from the final volume, we get the difference, and that difference is going to be the volume for the object that I'm using. In this case, the volume is recorded in milliliter, but 1 milliliter equals 1 cubic centimeter. So when you are recording the number as the volume of the solid, you should change the unit from milliliter to cubic centimeter. So we're going to look at this number and record this number as accurate as possible. It's between 82 and 83, and you estimate that number closely. Next, we are going to measure density of water. For density of the water, I need the mass and the volume. So I'm going to use a graduate cylinder, fill it up to exactly like 10 milliliter, and then measure the mass. But because I want the mass of the liquid, I need the mass of the container first. So I place the graduate cylinder on the scale. You measure the mass of the empty graduate cylinder first. Then we are going to transfer exactly 10 milliliter of water, because we want to have the mass and the volume. So pour as close as 10 milliliter, use a dropper to adjust the last drop until the meniscus is at 10, which is the lowest point of the curve. You already know what meniscus is at this point, but I like to repeat it for fun, I guess. So I have 10 milliliter exactly. You record this number. It's given, it's 10 milliliter. And you measure the mass again, and the difference is going to be the mass of water. When you have the mass before and after, you have the volume, you can measure, you can calculate density. Not every liquid is going to have the same density. We are going to measure now a density for an unknown liquid or unknown. Note that it's unknown B for this part of the experiment. So again, we are repeating the same procedure because it's liquid. I'm going to have the mass of empty graduate cylinder and record that number carefully. Okay. Then we add exactly 10 milliliters of the liquid. Again, I'm going to transfer by pouring, make it close to 10, adjust the level to get the meniscus to exactly to be 10. Okay, the meniscus is now at 10. You record this volume and measure the mass again. This mass is mass of the liquid plus the sample. See, it fluctuates because the number is the pressure of the air can affect the liquid. Is unknown liquid. It can evaporate over the time. So when it's stable, you record the number, and you record the number that you saw. It's close enough to the actual mass. This it's done. Part 3, it's done at this point. Okay. This technique is to turn on a Bunsen burner and adjust the burner. Bunsen burner is used often in chemistry lab, especially in inorganic and general chemistry lab, as a source of heat. It can provide like very high heat up to like 1500 degrees Celsius. Of course, there is a chemical reaction that is going on and is happening, and one of the byproduct of that chemical reaction is the flame that you see, is the heat that is generated. This chemical reaction is a reaction of gas, a natural gas reacting with oxygen and producing heat and flame. The byproduct of that is water, or the actual products is water and carbon dioxide. Now, if you don't give enough oxygen, instead of carbon dioxide, we will have carbon monoxide production. Carbon monoxide, when it's produced, the flame is not hot flame. The carbon monoxide is a toxic gas. It's going to cause like smoke, and it can contaminate the equipments and glassware that you're trying to heat up. So how to get a good flame? What are you going to adjust? We have 3 valves that we want to adjust. This is a main gas valve, and on top it says gas because we do have other valves that it says like a vacuum, or it says water, or for W, or VAC for vacuum. This is gas, blue color in this lab. There is another valve underneath that this valve adjusts how much gas is being let in to mix with the air for this reaction. And the old rule of righty-tighty, lefty-loosey, it does work. If you want to open it, you turn it to the left side like 2-3 times. I usually do like a 3 round. With the design of this Bunsen burner, when it's all the way closed, I'm gonna have to open like I usually do like 3 full round, and with this 3 full round, and I just tested this, it required a little bit more, like maybe 4 or 5 full round, to make sure I have enough oxygen mixing with this. I turn on the main gas valve. At the same time, I'm going to strike. Before you actually turn on the main gas valve, because you don't want accumulation of the gas in your workstation. If you have too much gas and then you strike it, it can catch on fire. So you want to make sure everything is working before you turn on the gas. You want to make sure your striker is working. And the way this striker is designed to work, as you slide these 2 stones against one another, is going to generate spark. If it doesn't generate spark, there would be no fire. And sometimes students, when they are striking, they lift this up, and if you lift it up, even though you are sliding, but it's not engaging and is not going to create spark. So you know how to use this. Make sure you can generate the spark. Then you turn on the main gas valve and strike. When you strike, you want the color of the flame you want like a blue color. When it's a yellow color, that's the indication you don't have enough oxygen and carbon monoxide is being produced. So again, you turn this cylinder and to the left side, again, righty-tighty, lefty-loosey, and how much are you going to turn until the yellow color goes away? A perfect flame would be blue color with 2 or 3 cone. You see, and they're all blue color and different shade. You could see that cone, when the tip of the inner cone, that's the hottest part of the flame. So when you are using this, if you want a hot flame, you want to make sure that the object or the level of what you are heating is going to be adjusted to the top of the inner cone. For a cooler or lower temperature, you have to increase the distance. You can lower the amount of the gas for lower flame, but never yellow color flame. And when you are done with this using of the Bunsen burner, first thing you want to do, you want to make sure that you close the main gas valve. And then you can close the gas adjustment valve or leave it on for the next students, but I always like to start with the closed gas valve because I know how much gas is being added and adjust the level of the oxygen. Part 4 of experiment 1, we are going to measure boiling point for liquid. Boiling point is a temperature where the liquid changes to gas. To measure the boiling point, we are going to use hot water bath. So the sample we are measuring the boiling point cannot have boiling point higher than 100 degrees Celsius because that's the highest temperature we can get with water. So to set up the hot water bath, I'm using an iron ring stand. I attach the iron ring. The level of the iron ring, it's important because I don't want to have it too far up or too low because I know I need to place my Bunsen burner about like the 2 inches below the ring. So I attach the iron ring. I use a wire gauze and I will fill up a burette like halfway with water. I place on the wire gauze. I'm using a thermometer clamp to hold my thermometer, and thermometer is going to measure the temperature when the liquid starts boiling. The sample that I'm using for boiling is going to be placed in this sealed glass tube. It's a small, like a tiny test tube. I attach to the thermometer using this rubber band. The sample that I'm going to measure is going to go inside this sealed tube and then placed in water. So let me just add the sample as I'm talking, and also I am going to add a capillary tube. The first sample that we are going to use is ethanol as the known sample. I just use between like 5 to 10 drops, no more, add to the seal tube. Okay. If it's done in the fume hood, it's better, but I just want to show how just 5 to 10 drops of the sample into the seal tube. Then I take a capillary tube and I place the capillary tube with open end down. This capillary tube has closed end and open end. Open end down inside the seal tube. I place the entire setup of the thermometer in the hot water bath or inside the water. How low it should go, I want to make sure that the sample is immersed in the water, is placed inside the water, and I don't want it to touch the bottom of the beaker, which is the source of the heat. Then you already know how to adjust the Bunsen burner. You're going to turn on the Bunsen burner, adjust the level of the oxygen, and place it underneath and wait for the sample to start boiling. And I tell you what happens when it starts boiling. When this sample, I see that now it's the temperature is going up because it's being heated. When the sample starts boiling, it's going to change to gas. And this capillary tube that I have here, the liquid inside the capillary tube also starts boiling, and since it's gas, it's going to come out of that open end of the capillary tube. It's going to come out like very fast. When it comes out very fast, the temperature of the water is close to boiling point but higher than the boiling point. At that point, I'm going to stop heat, turn off or remove the Bunsen burner, and wait until the bubbles stop coming out and the liquid is going to go back in the capillary tube. Because first, when I place the capillary tube in the liquid goes inside the capillary tube. When it changes to gas, it's going to come out. Then when I turn off and when the temperature drops to exactly to boiling point, the liquid is going to go back up in the capillary tube. So just as a kind of making sure that it's clear, if the temperature is higher than the boiling point, the bubbles are going to come out very fast. When it's at lower than the boiling point, the liquid would be all the way into the capillary tube based on the capillary action, and no bubbles. But what we want to catch is the exact moment or the temperature then that the bubbles stop coming out and before the water going back up into capillary tube. We are waiting for that moment now. Okay, you see the bubbles are coming like very fast now. Those bubbles, a stream of the bubbles coming out very fast. Now is the time for me to remove the Bunsen burner and let it cool down, and we are waiting for those bubbles to stop coming out. If the temperature of the water is going to be too high, it might take longer and the sample might evaporate completely. So I'm adding a few drops of water to help that also. When you see the bubbles now, they are coming out a little slower, but still is too fast for me to record the temperature. So we are going to wait for the bubbles when it comes like one at a time and then stops. Okay, the bubbles stopped. Now we can record this number for the boiling point. And it is very close to the boiling point of the known sample. Okay, we are now going to make a sample with our unknown, and this time we are using unknown A. For the unknown A, I need another seal tube. Okay, need to attach the seal tube. This is for the unknown. The level of the seal tube, I like it to be very close to the thermometer bulb. I place a capillary tube in with the closed end up, open end down. It goes inside the seal tube. And I place my unknown, because we already done with the known sample. I'm going to place a few drops of the unknown into the seal tube. And we place this in the water bath. The water bath that I used, it's already hot, so I'm going to add some cold water to it to make sure the temperature is not higher than the boiling point of my sample. So what happens in there, if the boiling point of the sample it's less than the temperature of the water, as soon as I place it, it starts boiling. It doesn't give my thermometer enough time to adjust and show the actual boiling and the temperature. So we are going to place the sample proper level again. We want to make sure that the liquid is inside water, and we'll just show you the capillary tube where it's located. The bubbles that kind of started because the water was warm start coming out, and we are going to turn on the Bunsen burner, place it underneath, wait for boiling. We are waiting for that fast stream of the bubbles At that point, I will stop the Bunsen burner or turn off the Bunsen burner and wait for the bubbles to stop coming out. We see the bubbles coming out now. That means it's close to the boiling point. When it comes out very fast, that's higher than the boiling point. Then we wait to cool down again to the boiling point. Okay? You should see that the line is coming out now. It's not like separate bubbles. It's the line. The temperature now, it's at the boiling or higher. I turn off the Bunsen burner and wait for it to cool down, and it comes to like one bubble at the time. That's going to be very close to the boiling point of the sample. You don't have to add water. I'm just adding water to make it faster for recording purpose, so you don't have to watch video for too long. Okay. Now it's separated. You see that the bubbles are coming one at a time. I could see separate bubbles coming out. And we can focus on the temperature now and record the temperature with the close-up. Now one bubble at a time. Now we record the temperature here. That's the boiling point for our unknown sample, which you record with 1 decimal place using this close-up. When you are done with measuring boiling point, of course, you are going to separate all these components, different equipments that you use. The only part that I want to make sure, you turn off the Bunsen burner. The beaker is hot, do not touch it, and proper equipment for that to be using a beaker holder. And with the beaker holder, you can remove it, place it on the side until it's cold, and you can touch or take it to the sink and dispose the hot water. That's the end of experiment 1. Make sure you download the worksheet first before you start watching the video, and as you watch the video, record all these numbers, then you complete your worksheet before you submit. Thank you.